Hello students, in this video we are going to learn a very important concept from chemical kinetics, that is the rate law expression. Now let's see what is rate law. So the rate law is the relationship between the rate of the reaction and the concentration of the reactants. I repeat, it is the relationship between the rate and the concentration of the reactant. Now let's take a simple example. A plus B gives C. Here the capital A and the capital B are the reactants while the capital C is the product. While the small a, small b, small c are known as the stoichiometric coefficient. As we have seen, we have to write rate in terms of reactions only. Okay. The rate law for this reaction will be rate is directly proportional to the rate of the reactants only. Here the reactants are A and B. Concentration of the reactants will be always denoted in the square bracket, children. Always remember. Okay, here I'm going to add a little small alphabet X and Y. So watch till the end of the video to know about it in detail, students, what these X and Y are. Okay, now to remove the proportionality symbol, I'm going to equate it with the proportionality constant. K. Concentration of A to the power of X, concentration of B to the power of Y. So this will be the rate law expression for the this reaction. Okay. So here the K is the rate constant. A and B are the concentration of the reactant. X and Y are known as the orders of the reaction. Note it down, students. X and Y are the orders of the reactants. Okay. One more important thing to remember is that, students, rate of the reaction depend on the concentration of the reactant. That is, rate of reaction is directly proportional to the concentration of reactant. So when the concentration of the reactant increases, the rate of the reaction also increases. When the concentration of the reactant decreases, rate also decreases. Okay, students, it's very important. Now let's see a simple example where most of the student gets confused. Okay, for example, let's take this. PCl3 plus Cl2 gives PCl5. Here there are two reactants. One is PCl3 and the other one is PCl2. So when we see the stoichiometric ratios, all these things have stoichiometric ratios as 1. Okay. Now let's write the rate law expression for this reaction. So rate will be equal to proportionality constant K, concentration of the reactant PCl3 and Cl2. So as per the rate law, we have to add the X and Y as the power. Here the X and Y are the exponent. So if we compare this with the previous problem, okay, the previous equation, that is this one, here the A, B, C are the stoichiometric coefficient. And here the stoichiometric coefficient is 1. Everything has 1. So in some cases, the stoichiometric coefficient will be equal to the power. Okay, it will be equal to the power. That is the X and Y. So what will be the rate of this reaction then? So rate is equal to K PCl3. So what is the stoichiometric coefficient of PCl3? It is 1, right? Yes. Then we have to put 1 there. And for Cl2, What is the stoichiometric coefficient for Cl2? It is also 1. So that's it, students. So in this case, stoichiometric coefficient is equal to the power, that is x and y. So this is the rate law expression for this equation. Okay, let's see some other example. 2NO plus O2 gives 2NO2. Here, the NO and the O2 are the reactants. Here, the stoichiometric coefficients are 2 and 1. Okay. Now let me write the rate law expression for this reaction. So rate is equal to K to the power of NO. Let me write it X here for now. O2Y. As from the previous question, we have seen that stoichiometric coefficient is equal to power, that is X and Y. So if I substitute as per that NO, here the stoichiometric coefficient is 2 and O2. Here the stoichiometric coefficient is 1 for the O2, right? But in this case, student, the rate law expression is wrong. Is wrong. This is not a correct law expression for this reaction. But it's right in this case. Okay, it's right in this case. But it's not right in this case. So the correct one will be rate is equal to K to the power of NO to the power 1, O2 to the power 2. So this is the correct rate law expression for the reaction. Because children, so here the powers in the rate law is not equal to the stoichiometric coefficient. This is one important thing to note. Here the stoichiometric coefficient is not equal to the power. So why this happens? Very important thing to note, children. It's because this x and y are experimentally determined. Experimentally determined. So always remember this x and y may be equal to the stoichiometric coefficient or may not be equal to the stoichiometric coefficient. So the answers are 50-50. 50% it might be true, 50% it might not be true. So we can only find these values of powers, this x and y, only if the values of the experimental data are provided, okay? So don't worry about it. In the upcoming videos, I will post how to find the values of powers, that is the x and y, okay? Okay. From this, what we have learned, student, the rate law is totally based on the experiments. Okay, only if they provide the data, we can find the value of the x and y. This is the first thing you have to remember. And the second one is the power will not always be equal to the stoichiometric coefficient. That's all about the rate law. I hope it is clear and simple. In the next video, we'll explore the order of the reaction and the rate constant in detail. So if you found this helpful, don't forget to share and subscribe and like. Thank you, students.